Welcome to one and all. Myself, Dr. V. Sharan Raj. Let us continue with the subject Metallurgy of Welded Joints, Session 2, Unit 1, Metal Crystal Structures. In the last class, we saw what is electrolysis process, what is an atom, crystal structure, what does the atom consist of, what is unit cell, and various types of things. Let us see what are the types of crystal structure. As I explained, what is crystal structure? It is nothing but the atoms are arranged in a regular polyhedral form by the action of intermolecular forces of an atom. In a similar fashion, here, based on the arrangement of crystals in unit cell, based on the arrangement of crystals in a unit cell in the space lattice is a volume, it's a open space. When you compare that, when you compare the metal structure based on the arrangement of crystal in a unit cell, the crystal structures are classified into four types. One is simple cubic unit cell, we will call it short form as SC, simple cubic. Second one is body centered cubic unit cell, BCC, in a simple form it is body centered cubic. Next is FCC, face centered cubic unit cell, FCC we will call it as. Next is hexagonally closed packed unit cell, HCP, hexagonally closed packed. So out of all the four types of crystal structure, let us discuss in detail. In our syllabus, it is only three types of crystal structure we are going to deal with that. One is BCC, FCC and HCP. Let us see what is BCC. So, if you see in a BCC crystal structure, what happens? In the figure you can see, the first sketch you can see, they are taken a cube. In this cube, at the corner of each side, you can see the atom is shared. The atom is shared at the each corner of a body. So you can see the red atom, only one at the center. This one is at the body center. It is common for all the faces. How many faces will be there in a cube? If you see the cube, how many faces will be there? All, if you start from counting the faces, usually what happens? It will have four sides. There are four faces. And top and bottom, each face we will have it. So total number of faces will be equal to 6. So ನಮಗೆ ಎಲ್ಲ ಸೈಡಲ್ಲೂ 4 ಫೇಸ್ ಇರುತ್ತೆ ಕ್ಯೂಬಲ್ಲಿ. ಟಾಪ್ ಮತ್ತು ಬಾಟಮ್ ಒಂದೊಂದು ಫೇಸ್ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ 6 ಫೇಸಸ್ ಆರ್ ದೇರ್ ಇನ್ ಎ ಬಾಡಿ ಸೆಂಟರ್ಡ್ ಕ್ಯೂಬಿಕ್ ಯೂನಿಟ್ ಸೆಲ್. And if you see here, in the second sketch, you can see here, the center atom is only one atom, it is full. There is only one atom which is full. And if you see at one face, there are one atom shared by 4 corners. So if you start counting how many atoms are there in body centered cube, will be one full at the center, and this 1 by 4th, 1 by 4th, 1 by 4th, 4 into 1 by 4th will be equal to 1. So 1 plus 1, number of atoms will be equal to 2 atoms. So let us see what is body centered cubic. So body centered cubic unit cell is as shown in a figure. So the BCC arrangement consists of an atom at each corner. At each corner, you are going to find the atom, and another at the body center of a cube. Another at the body center of the cube. So in this case, a central atom in BCC cell would be equal to, what is the number of number of cells in this particular things? That is 2 atoms. How it is 2 atoms? One at the center, and at the each corner you can find 1 by 4th, 1 by 4th, 1 by quarter. Each quarter, if you are going to add each quarter plus quarter, half plus this, so it is 3 by 4, then it is 1. So totally will be equal to 1 atom at the corners, 1 atom at the center. So number of atoms will be equal to 2. And iron as a cubic structure, where do you find this type of structure? Iron is one of the which is being used widely today in applications. So iron has a cubic structure, and all other metal processing these structures are, some of the other metals are molybdenum, vanadium, manganese, tantalum, chromium, and some of these applications etc. are the materials that is being used in the this BCC structure is being there. And when we say BCC, what is the unique characteristics that defines BCC? That is known as atomic packing factor. What is atomic packing factor? How well the atoms are bonded together. One atom to the another atom, how it is being bonded together. If atomic packing factor are more, if it is more, I say the strength of the material is more. If the atomic packing factors are less, then the strength of the material will be less. Means atomic packing factor more means number of atoms, more number of atoms are packed. It is a dense material. If it is a less atoms are packed, then the atomic packing factor will be very less. So atomic packing factor for BCC will be 0.68. One thing you should remember in BCC is atoms are shared at each corner, and only one atom will be at the center. So how many atoms will be there in this body centered cubic? Only one atom will be at the center. One full atom will be at the center. So number of atoms will be equal to 2, and you will find it in various materials like chromium, molybdenum and all. And atomic packing factor of this is 0.68. Let us go to next slide, which is known as face centered cubic. So usually whatever the material you get today, for example, you are going to perform various operations in a lathe. You have performed various operations in a lathe. You are going to conduct various tests in material testing lab. So the specimen whichever you have it in your hand for testing, the sample specimen which you are going to collect it, which will be there in your hand, that will be BCC structure. When you heat that material, so about 723 degrees centigrade, recrystallization temperature we will call it as, above 723 degrees centigrade we will call it as hot working. So when you heat above this, then the material structure will be FCC. So this is a FCC is a structure which is very essential for forming any shape of a material. So ಈ ಮೆಟಲ್ನ ನಾವು ಹೀಟ್ ಮಾಡಿದಾಗ ರಿಕ್ವೈರ್ಡ್ ಶೇಪ್ಗೆ ನಾವು ಈಸಿಯಾಗಿ ತರ್ಬೋದು ವಿತ್ ಎ ಲೆಸ್ ಫೋರ್ಸ್. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಮೋಲ್ಡ್ ಇನ್ ಟು ಡಿಫ್ರೆಂಟ್ ಶೇಪ್ ಅಂಡ್ ಸೈಜ್. ಸೊ ದಿಸ್ ಇಸ್ ಆ ರೆಡ್ ಡಾಟ್ ಕಂಡೀಷನ್ ನಾವೇನಂತ ಕರಿತೀವಿ FCC, face centered cubic. Let us see face centered cubic. As I said, how many faces will be there in a cube? I said 4 at the sides and top one and bottom one. Total number of faces will be 6 faces. So here in this case, so the first sketch you can see, so face centered cubic is just shown in a figure 1.3. So here you can see in each face there will be one atom. Here you can see in each face there is a one atom. In a green sketch you can see in each face you can find one atom. So there are 6 faces. So 6 atoms are located at the center of 6 faces. As I said, so 6 faces are there. 6 atoms are located at the 6 centers. Each will be equally shared by the neighboring cells. If you see, it is equally shared by the neighboring cells. So half will be there inside this FCC and half will be at the another atom which is adjacent to it, so that the bonding will be perfect. So each will have be shared equally by the 2 neighboring cells. 2 neighboring cells ali equal agi share agirutte. Then what is the total number of atoms in FCC? So let us see. Thus the total number of atoms in FCC cell will be equal to 1. What is this 1? 1 is the corner edges. If you see the corner, there will be 1 by 4th, 1 by 4th, 1 by 4th, 1 by. If you add 1 by 4th of all the 4, you will get 1. What about this 3? What about this 3? Where did you get this 3? So as I said, there are 6 faces. It is equally shared, half of that. Because half will be in the another crystal, half will be in the another crystal. So it is only half of it, half into 6, which is equal to 3. So 4 atoms, number of atoms will be equal to 4 atoms. Among the metals having FCC structure, are copper, aluminium, lead, augmentum. So all this silver, all these materials you will find iron, calcium, and all these materials you will find a FCC crystal structure. Atomic packing factor of FCC. Atomic packing factor of FCC will be 0.74. When you compare with body centered cubic, face centered cubic strength is more because more number of atoms are there in a unit cell. There it is 2, here it is 4. When it is 2, when it is 4, obviously the metal strength should be more. Where does this indicate? So atomic packing factor of FCC is more. So this atomic packing factor of FCC is 0.74. Please remind there are number of atoms in FCC is 6 atom. So number of FCC atom is 4 atoms. Atomic packing factor is 0.74. So let us see what is HCP, hexagonal closed packed unit. In HCP, in the sketch you can see the crystal structure is in the form of hexagon. Hexagon closed packed is shown in a figure. So in this case, what you can do? In this case, so the arrangement consists of 6 atoms at the 6 corner. You can see hexagon means 6 faces. So 6 atoms are there at the 6 corners plus 2 atoms at the center. Can you see there is a 2 atom at the center here? 2 atom at this centers. In addition to that, there are hexagonal crystal structure here. So it is nothing but here you will have a 3 atoms at the center. So 6 atoms at the 6 corners, 2 atom at the center, 3 atoms at the body center. Face center 2 atom, body center 3 atom. So how many number of atoms are there in HCP? If you start counting it, how many atoms you are going to get in this? So if you see that, so if all the 6 spaces, it is 1 by 4th. 1 by 4th means 1.5. 1.5 plus 1.5 is 3 atoms. And if you see this 1.5 plus 1.5 is 3 atoms. At the center there are number of atoms is 3. So 3 plus 3 will be equal to 6 atoms. So HCP is found in metals like beryllium, magnesium, calcium, zinc, cadmium and titanium. So this is HCP material is found in various applications. Atomic packing factor of HCP. Atomic packing factor of HCP is 0.74. So the BCC atomic packing factor and the HCP atomic packing factor is same 0.74. So this usually, even though HCP and FCC is there, we go for FCC crystal structure because that is easy for us for manufacturing and handling purpose, and that is easily formed. So as I said, when a body is in a cold condition, it is in BCC structure. When the body is heated, it goes to the FCC structure. So once you cool it, it comes back to its BCC structure. When you heat, it may go to either FCC or sometimes HCP. When a heating condition is there, so when you heat the metal red hot condition, that condition can be either FCC or HCP. You have to identify which phase it is. Next, when you cool it, it comes back to its BCC structure. So this is the let us brush up what exactly we have studied today. There are 4 types of crystal structure. So SCC, BCC, FCC and HCP. And you saw what is BCC. Only one element will be there, only one atom will be at the center of a body, and all corners, 4 corners will be shared by 4 atoms, 1 by 4. So number of atoms is 2, atomic packing factor is 0.68. Coming to this FCC, in FCC we saw what is known as face centered cubic. So this is a very crucial stage where we use the material. So in this we found that number of atoms are 4 and it will have all the 6 spaces will have an atom shared by the neighboring cell, and atomic packing factor is 0.74. And in HCP we found that it is hexagon enclosed mat similar to that of FCC. Atomic packing factor is 0.74, but number of atoms here it is 6. So number of atoms in HCP 6, number of atoms is 4 in FCC, number of atoms is 2 in BCC. So let us start with a MCQ. So multiple choice questions. First question: atomic packing factor of BCC unit cell is, dear students, that I have already explained. Atomic packing factor of BCC unit cell is A 0.54, 0.68, C 0.74, D 0.80. So the answer is 0.68. So what I can say, 68 percentage, if you convert it into percentage, 68 percentage will be the atomic packing factor, or 0.68. So next question: the atomic packing factor of FCC unit cell is, what is FCC unit cell? So FCC unit cell is A 0.54, B 0.68, C 0.74, D 0.80. So the atomic packing factor of FCC is 0.74. Atomic packing factor of HCP unit cell, third question: atomic packing factor of HCP unit cell is A 0.54, B 0.68, C 0.74, D 0.80. So the answer is 0.74. 0.74 is the atomic packing factor of hexagon enclosed unit cell. So next you can see the fourth question: in which unit cell arrangements only one atom is located at the body center of a cube? So dear students, you know that only one atom is present at the center of a body. Then it should be what? A BCC, B FCC, C HCP, D none of this. Only one at the center of a body. Then it should be BCC, body center cubic. In which unit cell arrangement atoms are located at the center of a 6 spaces? The fifth question says that what is the unit cell arrangement of atoms are located at the center of 6 spaces? A BCC, B FCC, C HCP, D none of these. So it is FCC. FCC is nothing but, so in these unit cells they are located at FCC. Total number of atoms in BCC. Total number of atoms in BCC. Sixth question: total number of atoms in BCC. How many atoms will be there, dear students? Whether it is 2, B4, C8, D10. How many atoms? It is 2 atoms. One at the center of a body, and all the corners, 4 corners, it is shared by 1/4. If you add, you are going to get 2 atoms. So next, seventh question: total number of atoms in FCC. How many number of atoms are there in FCC? A 2, B 3, C 4, D 6. As I said, so each faces there is half atom shared by another one, half atom will be its own original one. So that is 6 into half is, so 6 into number of atoms will be equal to, how many number of atoms will be there in this? So here it is, number of atoms will be that. So the answer will be, number of atoms is 4. So number of atoms should be equal to 4. 2, 3, 4, 6. What is an answer? Answer should be C is equal to 4. Let's see total number of atoms in HCP. Total number of atoms in HCP. So total number of atoms in HCP is equal to how much? So total number of atoms in HCP is A is equal to 2, A is equal to 2, so B is equal to 3, so C is equal to 4, D is equal to 6. So total number of atoms in HCP should be equal to how much? 6. How it is 6? Each corner, there are 6 atoms shared by each corners, 1/4. If you go on adding all 6 times, it is 1.5. Bottom 1.5, top 1.5. So totally will be equal to how much? 3. 3 and 3 at the center of an atom. 3 at the center of atom will be equal to how much? 6 atoms. Ninth one, in which crystal structures atoms are located in hexagonal structure? Atoms are located in hexagonal structure. In which crystal structure hexagon structure is there? So honeycomb structure, we will call it as honeycomb structure. So if you see the honeycomb, see, so the honey, the whatever the net it is going to form, that comb is like honeycomb structure. It is an hexagonal structure. So HCP is a one structure in which crystal structures are hexagon. A BCC, B FCC, C HCP, D none of these. So HCP is the right answer. How many types of crystal structures are there? So the first question, the first slide we explained how many types of crystal structure are there. A 2 types, B 4 types, C 8 types, D 10 types. So answer, the correct answer is 4 types. So there are 4 types. One is SCC, one is BCC, one is FCC, another one is HCP. Dear students, thank you so much for your patience listening. So thanks for one and all.